Welcome, everybody. As Jonathan said, today is part one of a two-parter. So we're actually going to be looking at this car park design in our next session in a week's time. So really encourage you to stick it out and register for the next one because then we'll be doing the tail end of this whole process. So what are we looking at? We are going to try and look at car park design from a workflow process. So what does that mean? Hang on, get the PowerPoint working. Here we go. Um, so let's set up a scenario. You've been tasked with taking a concept from a layout, which is just 2D line work, someone's dreamt it up sitting in the boardroom, to full design, pretty much like the pictures on the screen here. So where do you start? How do you get from A to Z? It's always multiple ways to approach things. In my experience, it's be whatever's easy at the beginning is usually painful at the end. Whatever's more challenging at the beginning is easier at the end. So it's kind of like the Rob Peter to pay Paul territory. So as I mentioned, this is a two-parter. So part one, which is today's session, is all about modeling. So this is where we're going to have a look at how to set up the models, how to do some design work. And then part two, which is our next week's session, is looking more at the output. So that's where we're going to look at things like long sections, cross sections, exporting the models, volume computations, subgrade, if we don't get to it today, might be at the very beginning, but all of that sort of regular stuff, but important stuff. So it's the things that some people tend to take for granted, but stuff you really need to know about. All right. Um, so, as I said, the task for this particular exercise is about upgrading some parking facilities. So the survey's been done. So we've been given a terrain model and some existing line work to represent all the features that's already sitting in the model. Project manager has endorsed the concept layout. This is the one that they want to go with, well, at least at this point in time. Like I said, how do you start the modeling? Where do you go? What's the beginning? So the general workflow, and I would say this is probably general for most projects, not specifically car parks, just this is the one I've picked on for our exercise. You need to start with the alignments or the horizontal control. So you need to convert that concept into a series of alignments or polylines or combinations of to give you your horizontal control, your 2D layout. You then need to develop up some sort of cross-sectional shape or shapes templates that you would be applying to those strings or those alignments to generate your string models, which is your next bit. So you generate up all your string models, you model everything, you then go through and design and edit and manipulate because nothing's ever consistent. It's not greenfield design. And then you do your outputs. So that's your general workflow. And that's the approach we're going to take with this particular exercise. So today is pretty much the first four pieces. And then next week is the outputs. Although I'm going to probably flag it up front that the tail end of some of the design and the editing we may end up actually having to do at the beginning of next session, depending on how we go for time. So the approach, what am I using? There's quite a lot of bits of the software. So I am actually using Civil Site Design sitting on top of Civil 3D. But this approach would equally work for Civil Site Design sitting on one of the CAD platforms, or even the Civil Site Design Plus sitting on the OEM. We're going to use road and profile strings, network strings. We're going to look at using templates. They're kind of all the foundational stuff. We're going to use Project Assist to leapfrog ourselves to get the model set up. We're going to touch on the intersection manager functionality that's been added to the software in the last couple of versions. We're certainly going to be in and out of the vertical grading editor. We'll be utilizing functionality like the auto profile, the design constraints. We'll play in the grid editor. We'll muck around with a couple of variations. We'll even touch on a little bit of the CSD surface labeling. Model viewer is going to be part and parcel of this so that you guys can probably see what it is I'm doing because it'll look like cross sections and long sections in the VGE and the cross section view till I bring up the 3D models. We'll touch on and utilize quite extensively the surface extension models. We'll play around with the surface manager, looking at how you can trim up triangles or make manipulations on your surface in terms of the tin. We'll definitely be mucking around with model builder. And we'll also have a look at the subgrade model to kind of model that underground piece, create the datum surface. Okay, so this project, and you may have seen this project before. I've got a little slide at the end here that I'll get to in a minute, but this is a data set that I know Jonathan used probably about 12 months ago, looking at Model Builder as an exercise. I think it was Model Builder 101, Jonathan. Um, and it
Yes,
is,
yes, Model Builder 101.
yeah,
Sorry, caught
I've
me
got a
off guard
slide.
there.
No, no worries. I got a slide at the end that's got that. So, I mean, it's a really good reference because it's another way to approach this project, but I'm taking a slightly different track on it. I am using a similar data set, but I am looking more to leverage some of the newer functionality components in civil site design, like the project assist, surface extension models, subgrade model manager, all that sort of newer stuff that you may not be so familiar with. Now, that layout that I showed you, the green sort of hatchy outline, you could probably approach it in two ways. Um, One would be to design the outer strings and join it all together with Model Builder, which is perfectly valid. But I'm choosing in this exercise to actually model it as a couple of roads. And the main reason is because of this intersection down here. Because these two bits of the models kind of join together, it lends itself to trying to leverage off the intersection functionality in the software so that I can generate up the curve returns for sort of here and here and link all of that together automatically. Use the software to do half the work for me. And then all I really need to do is generate up the connection to the parking bays. So I'm going to use these light green alignments here to control my road edges because the shape of that road is not a consistent cross section. So the template will not work quite well, particularly going around things like the corner here. There's a widening going on here. Up here, there's a widening going on. So I need some sort of horizontal control to control those. And then obviously the parking bays themselves. So I'm going to put three indented bays onto this network of roads. And then I'm going to model up these bays to link up with the road so that they actually join together properly. As I promised, or as I mentioned, the webinar that Jonathan did was that Model Builder 101, which was about 12 months ago. It is on our YouTube channel. There's a QR code there if you want to scan it and then you could jump to it, but you could certainly just go to the Civil Survey Applications YouTube channel and look up our webinars and you will find the Model Builder 101 there. And that is a really, really cool and certainly appropriate for this type of project. All right, let's get into it. So, as I said, I'm using Civil 3D. So my alignment creations will be using the Civil 3D functionality, but if you were using the CAD one, then you would be creating these alignments using the alignment functionality in Civil Site Design. So the process is slightly different, but the same outcome. Okay, so as I mentioned, the green and the red here is the proposed sort of concept layout. That's just probably sitting in there just to give you guys an appreciation for the physicality of what it is I'm trying to model. I'm starting, just to be clear, I'm starting from fresh. The only element in the model in here that actually is already done for me is my natural surface. And this was built from the survey data, which is all the line work sitting in here. And it's a series of break lines and actually a series of AutoCAD points with the boundary thrown on the outside. And then I think there's a few extraneous levels in there. So I'm pretty sure in the surface definition, I actually went in and killed out. Yeah, I did. I killed out everything below zero because I think there's a few zero level lines that just completely and utterly were gutting the model. The surface that I am using is nothing extraordinary. So if I kick open Model Viewer, I'll show you what it looks like. When it boots up, here we go. So there's my survey. Pretty flat part of the world. Fair bit of formation sitting over here, where there's an existing car park. There's an existing road down here. Maybe I'll shrink this down. Maybe it'd be better to talk about this in the plan rather than the model viewer, which is a bit out of context. So there's an existing car park here, which is the one sitting up here to the north. There's an existing road down here. And then there's an existing road over here. So we've got to kind of link the whole lot up together. Okay, so first things first, let's get our alignments sorted out. So I need to do a bit of cleanup in here. So I'm just going to freeze a few things off so that makes it a bit clearer. I'll keep the red and turn on some stuff. Okay. So alignment creation, Civil 3D, pretty much home tab alignment. So I'm going to create the first one from objects. So I'm going to pick on this one over here. This is going to become my first road, very aptly named road one. Not going to make any curves. I'll erase the objects, but I might tweak the labeling because that looks a bit spacious. So let's go down to say 5 meters. We'll get rid of the minors, and then we'll flip this out to being say that. And I'm going to save this one as I don't know, something so that I can use it again. So there we go. Some decent labels. Creation of Civil 3D alignments from layout is really no different than the way you would do it in the civil site design on CAD. You'd be the exact same process there. Um, but I thought just to reinforce that you don't have to always build your alignments that way, I'd actually make the second road alignment by layout, which is utilizing the Civil 3D layout tools. So this time I'm going to make it, but I am going to use that label set so that it automatically labels the way I want. So I'm going to say I want to start building with curves, tangents, add some curves in. Now, just make sure my snaps are running the way I want. Yep. So there are a few points in here that are actually ready to go. So I can just get the horizontal position where I want. But basically, as I start snapping in locations, the software's dropping in IP points and then just fitting in curves to go in to give me my horizontal changes. And then I can grab said curves and just go, well, that one's not quite big enough. And I can just drag it around graphically, or I can grab the pass-through point, make a change. So when you're doing some sort of reconstruction project, sometimes you don't start with the very beginning. Sometimes you go, oh, I need to fix or I need to lock in this radius. So you can, this is that concept where you can just graphically fit things around and then manipulate everything else to go with it. That's where the layout tools really shine. You can also do numerical editing with this stuff. So I can actually bring this up into the alignment grid view, and then I can start to manipulate the different parts of my curve. So you can see there's the first curve it highlights in the drawing. So it goes red. And then you can plug in the actual potential radiuses you want. So I can fix that to say 20 meters so that it's actually a defined value of what I want. And I do have some values I want for the rest. So I want that one to be 5.8. I want that one, which is this curve up here. It's a bit bigger. That should be more like 11. Oops, 11.8. And the last one I think is 5. So if you're ever trying to fit curves in, then you can do it graphically, but then this tool here to actually enter the values in numerically is a really nice way. I used to use this on a regular basis. All right. Now, next step is to potentially build all the other alignments that I was talking about, which are for my edge control, my parking bays. Save myself a little bit of time and a little less monotony for you guys. I am going to import the rest from an XML file so that I don't have to sit here and recreate them all. But before I do that, I do need to set the default labeling style, because if I don't change this value here, then every single one of them will get labeled in whatever my default style is, which I don't know about you guys, it drives me batty. I have to go and delete them. So I'm actually going to flip the default label set to none. And then when I run the import, pick my alignments, and that'll do. Bang. Brings the alignments in, uses the default labels, object style, but it doesn't label them because the default label sets to show no labels, which is what I want. If I look at my alignment list in Civil 3D, you can see all my alignments sitting in here. So now's the time to start to stylize them. So grab the 3 parking bays, pick those in the drawing, and I'm going to change them to look like strings. So that's a little different. Blue lines. And then my EB ones, these ones I'm going to do it from here, and I'm going to change these ones into my offset style just to make them look different again, so you guys can track what it is I'm doing. So blue ones are my parking bay controls. So that's that one. The green ones, or the light green ones, are my edge of road controls, and then the ones that are the orange and the yellow are the ones I'm using for the center lines. Okay, so that's alignment set out. let's move into the next sort of big phase, which is cross-section. So if I come over to my tool space in civil site design, I'm going to make a brand new template. So we're going to go new template local, we'll call it road. And we're going to start this thing from scratch. So I'm going to build a section. First section I'm going to build is a piece of pavement. So I'm going to call it my EB. And I'm going to make it just a generic width and a generic crossfall. I am going to add some materials so that when we get to the effort of making some subgrade, it's actually going to create something for me. So there's a bit of road pavement. Now I'm going to throw in a bit of curb, but I'm only going to do a two-piece curb for this one. So I'm going to ignore the invert. I'm going to start straight with the topper curb. And my topper curb is only going to be 40 mils wide and 150 mils tall. That's going to be back curb and 110 0 topper curb. Both sides, curb depth 0.2. I'm going to go no extension on this one. And we'll go depth of, say, 130. That one's concrete and that one's crushed rock. All right, so there you go. Got my curb and channel sitting in there. Throw in some codes. Then probably need a little bit of some sort of boundary, some sort of, I don't know, flat spot behind my curb. So I'm going to throw in a section. I'm going to call it boundary. So BDY, plot that. I'm only going to make this thing about 150 mils wide, 1% slope. Now I'm not going to put a material on it for anything other than to map the design surface when I get to the point of making a subgrade. And to do that, I do a zero depth material of a particular material type, doesn't really matter. So I'm going to pick on this infill. And when I do that, so because I've done that, when I get to the subgrade model, the subgrade will build the bottom datum of everything, including the bits that parallel up with the design at zero depth. I'll retouch on that when I get to the whole effort of making the subgrade model. So there's the left batter, something generic. We'll just go 1 in 1. But I'm also going to do that same idea of zero depth on the batter as well, so that my subgrade model will extend right through to the back code on the left and the back code on the right. I now need to make a template that will be appropriate for my parking bay. So I'm going to need to make one for the left. So this one, I'll create a new curb, same deal, 40 mils, 150 BK. Oops, sorry, that's TK. That's 110 0 BK. I'm only going to do this on the left because I only want to do this on the left side. Curb depth 0.2, subbase 0, subbase depth 0.13, concrete FCR. Show that up. And we will add in our BDY so they match up. 150, 1% left, 0. Do the same idea with the subgrade. And we'll do our left batter as well. Bang. Now I need to make a copy of this. So to make the right side version, so a copy of the template, I'm going to call it parking bay right. And then I'm going to come in here and I'm simply going to tell the software to mirror the template. Then I just got to fix up the batter conditions. So turn off the batter on the left, fix the batter on the right. And I've just realized I didn't do this on the other section, so I'll have to go back to it. I've got to put the zero depth on the batter. I should have done that, but anyway. So we'll go back to this one. Good bit is if you get these wrong, you can fix it up at a later date. All right. That's all my templates. I only really need 3 different things. Need the left parking bay, the right parking bay, and the typical cross section for my road. All right. So next bit is to start to make my strings. So I could normally go through the process, come up here and pick on one of my alignments, say here, right click road, create a profile, go that way. What I'm actually going to do So I'm going to take advantage of, well, not advantage, I'm going to use the Project Assist functionality in the software to leapfrog me to the point where all the strings are made, the model builder's been built, the edits on the model builder have been undertaken, and the software has begun to link things together for me in terms of levels. And that's what the Project Assist functionality lets you do. And you don't have to run this at the beginning. You can actually run this partway through. Maybe you want to drape some islands onto something. You could throw um, those in at a later date and you can just drape them onto your model. And then the Project Assist will go in and do the model builder edits for you based off the layout of your island. So it's a really, really useful tool to get your models so you don't have to sit there and do the nitty-gritty model builder edits. Best bit, it tells you everything it did to get to that model. So if you did want to deconstruct it, you'd get a PDF at the end, tells you all the steps it went through. So let me show you how it works. So I go Project Assist. Yep, target is NS. I want to see that output, the PDF. So the software will go in then and it will analyze the layout of your alignments and it'll make a prediction based off what you've done in the past. So this is the AI part of it, where it will then predict what those alignments are being used for. So it's worked out road 1 and road 2 are road strings, and then it's worked out pretty much everything else is some sort of edge control or a string. So in this case, it's pretty simple, straightforward, but you do have options for lots of different things. If you were modeling footpaths, if you're doing saw cut controls, boundary lines, islands, driveways, existing features, you're matching into existing roads, you can use these and it will begin to learn off your naming conventions what you use different string types to be, and then it'll take that knowledge and use that the next time you run the Project Assist. But I don't need to fix any of these because it's pretty stock standard names that it has predicted. If you ever need to work out where these things live, you can actually hover over these things and very nicely highlights in the drawing, not dissimilar to what happens with the tool space. So it gives you that spatial awareness as well. So I confirm that that's what I want to use each of those for. The reason I had built my templates, and I probably should have been clear about this, is that when you run the Project Assist tools, you need to have developed up your alignment layouts and your templates that you want to use to make your model. If you get to this point and you haven't built your templates, then you pretty much need to cancel, make your templates, and then come back. You need those two pieces first. All right, so basically this is the workflow. So you just work your way down the list and you basically start to answer or adjust the questions or options related to the particular string. So again, highlights in the drawing. So this is road 1. So my template for that I want to use is my road. I then look at the next one here, which is detected parking bay road 1 on the left. It's connected it. Well, it's going to connect it. And because it's not parallel, it's predicting that it needs to be a string. Great. It's exactly what I want. But I want a different template. So I'm going to pick my parking bay on the left. And then I go to this one. For some reason, it's thought that the parking bay road 2 on the right is actually connected to this. Well, that's not right. So this one here allows me to disconnect it. And then that now sits down at the bottom here as an unconnected, not associated with roads. And that's where I can just basically connect back up. And this time I can pick the road it should be connected to. So it actually should connect to road 2. And then if I go back up and have a look, the next thing for road 1 is actually the left edge of bitumen. And because it's not parallel, it's predicting it needs to be a string, which I don't want. I just want it for horizontal control. Same for the right. So that was done. Road 2, that's this road here running this way. So the sort of north-southy one. Same deal. I need to set the road alignment. I then need to start looking at the controls. So this one is the parking bay on the left. So that's a string. Great. But I need my parking bay left template. This is the right edge of bitumen. So that's horizontal. Left edge of bitumen. That's horizontal. Sorry, that's backwards. Left, right. Clearly, I know my left and right. And then the last one here is the parking bay, which is the one that we connected. That is a string. Great. But I want to have that as the parking bay on the right. Then down the bottom here is some options to how the software builds things, which is great. It's going to build me a model. It's called Design Model. Up here, I can set the Kerb return defaults, which is what's going to happen at this part of the model. However, the introduction of Intersection Manager has been also included in the Project Assist workflow now. So I can actually come in here and go Intersection Manager, and it says up here, this is road 2, road 1 intersections. So there's the road 2, there's the road 1. It's predicting, well, it knows it's a T intersection, and it knows that road 2 is the boss, and road 1 is the side road. And then it's basically allows me to set the values and the properties for each of the curb returns. So I want the left one here, so the start on the left, which is this one. I want that to only be really tight, something like 2.75, because it's a really sharp corner here. And the one on the right, a bit bigger, a bit more generous because there's a bit more space in this one. I actually want that one to be something like 4.8. And click on OK. Now I'm ready to make the model. So if I go compute, the software will go through and take all of those instructions and start to generate all of the models related to it. And then it shows me the PDF that it created, talking about all of the steps that it went through to achieve what it's just done, which is all of these things here. So it tells me different things that it's done. I've added model builder edits. I've added a variation to control the left edge of bitumen for road 1. And anytime you see one of these little cameras, it allows you to click on a link and it'll jump you to a video that talks about how that particular aspect works. So this one here would jump me out and have a look at adding new sections to a model. And then it'll tell you all the things it did to road 2. Then it'll talk about things that it did to make models. And that's pretty much it. There it is. Model builder edits added to the model. So nice bit is that PDF is stored wherever your project is, so you can always come back and review it. In terms of what it's actually done, over in my tool space over here, it's created 2 roads, road 1, road 2. It's created the 2 curb returns. So there's the curb return on the left and the curb return on the right. It's also then generated the parking bay strings. It has also then generated total model, which is just the intersection and the 2 roads. And then it has made a design model, which incorporates the parking strings. It also makes a thread so that if you ever need to redo that stuff, you can run the thread. And if you don't know what threads are, there is some great stuff on our YouTube channels about threads, but threads are essentially like macros where you can tell the software to repeat aspects of civil site design. So, recompute this vertical grading, recompute that vertical grading, plot a long section, plot a cross section for particular strings. Thread is essentially you building up that sort of macro. The AI Project Assist tools actually builds a thread based on what it did to make your model. So you can always rerun that thread if you ever need to. So let's have a look and see what it's actually done. So if I go back to Model Viewer and turn on some models. So I'll turn on the primary design, but I'll turn on total model first. And I might just change the background of this to be something from the drawing. I'm just going to turn it on because I think I froze it. I did. That one, I'm going to say 50%. And I'll turn the edges off because it's getting a bit messy. So that's just the base model that it started with for me. That model then, and I think, to be honest, when I built the road template, I got the codes backwards. I suspect I actually called it BK and TK instead of TK and BK. Hence why this has come up red. That's just operator error from me. I can see it. The second model that it built for me, which the software has aptly named design model, is actually a model builder model. It's got the prefix of the BM. If I bring that one in, this one actually begins to incorporate my parking bays. So you can see here the parking bay shoots out to the side, parking bay shoots out to the side over here, and the parking bay shoots out to the side over here. So it's leapfrogged me to the point of all I need to really start thinking about is designing these things. So if I actually zoom in and have a look here, clearly I've got some work to do here. The batters and the levels are way out of sync. That's part of the design exercise. But let's sort out the roads first. But now I'm really only at the point of doing the modeling edits. So I've gone through the alignment creation, the template creation, We've now done the string models using the project assist. Now we're up to the phase or the process of doing the design edits. I'll just turn some of the line work off just to clean this up for you. So let me just toggle display and turn a few things off. So let's turn off total model, leave those things on. So probably need to deal with the vertical designs of the roads. Let's have start on road two. This is the vertical design of road two. So the software hasn't done anything here yet. It's just done its stock standard auto fit to the terrain as best it can. So I need to start doing some design work. I'm going to guess the first thing you probably want to do is link this to the surface. So let's anchor that first IP down to the terrain model. I suspect you probably want to do the same thing at the other end. I then probably need to start looking at some cross sections. If I right click and have a look at that, you can see cross section here. But looking at the natural surface, this kind of leads itself probably to one-way crossfall. So instead of applying different template, I'm actually just going to come in and I'm just going to use a vary, and I'm just going to set the crossfall on the right-hand side to be positive 3%. So at least now this whole thing's one-way crossfall shooting to the left. You can see there that the contours have updated. It's built the model for me. So this thing's all live. Okay, next thing I probably need to start doing is come up with some sort of vertical design. I suspect 200 mils of lift here is probably a tad much. So let's throw in a new IP. So put something in, say there. And then I could use my graphical edits here to start dragging it around. Maybe even the same here. Probably don't want to come here. You might want to match grades. But if I want to be a bit more particular with my grades, probably want to set this thing to be out at say minus 1.5. And I probably want a 10-meter vertical curve, something like that. And then perhaps this one here, I want to do something a bit more funky. I'm going to come in here. I'm actually going to set in and out grades for this one. So I'm going to say the in grade for this is going to be my 1.5. Actually, I just realized that probably is a bit flat. Might change that. Oops. So I'm changing my mind. That should be maybe -2. That looks a bit better. Come back to this one. I'm going to do this one as an in and out. This one I might do a bit flatter at the start. And then here I might go out to 5 meters. Again, maybe a 10-meter vertical curve. Looks kind of a bit more reasonable. Cross sections here. So that's probably in the realms of possible and probable. Let's go with that. If you notice, if you haven't really played with road strings in great detail, the road one's showing up here. So that's actually the point where the other road joins in. So it will always show you side main roads in any of the vertical gradings that you're mucking around with. So don't be too concerned if that's not there because you haven't made necessarily the other road. But when that flashes up, that's where you've got a side road. So I've got to make sure the design here is what I want. So if I have a look at that one, sweet, looks pretty good. Let's move on to road one. So road one is running sort of, well, diagonal, but let's say it's pretty much going from left to right. This is the intersection joint with the main road. You can see here it's projecting the one-way crossfall in, but then it's adding in my ease controls in here, which I didn't play with the settings. So I need to play with that first, probably. I also probably, same deal here, need to anchor that to the terrain model. So ease controls or side road matching, depends on which part of the software you look at as the name we give it, is controlled on a road by road basis. And it's actually controlled on a region by region basis of the roads. And you got some default settings in the drawing settings that you can set as the defaults. But whenever a road is a side road and it gets into one of these ranges, you can actually change what happens. So I could turn this off and do full manual control on the intersection, or I could, what I'm going to do is actually reduce it. I want to go to something like 5-meter VC. Oops. And sorry, a 10-meter VC at 5 meters off the edge of the road. Do that. And if I actually deleted it, which it tells you you can't, when you do, actually reestablishes it with my 10-meter one, my 5 meters off the side. All right. I can also add IPs in a different way. And I'm going to do it here using the grid editor. So grid editor allows me to review the values of each IP for my model, but it also allows me to set grades forwards and backwards so that I can make sure things are grading the way I expect. But it also allows me to add in anything I want. So I can actually go to the blank line here and go, I want to add a new IP in at say 23 and a half. I do that and you'll see that throws in a new IP and it'll basically set the level to be the same as the previous. But that's okay. I can come in and start changing the levels. So if you've been given a design or you've got some numbers you want to go with, this is not a bad way of plugging it in. And then I can come across to the vertical design, vertical curve, throw that in. So you can use the grid editor as a quick way to add data if you want to. You don't have to. You can just click in and then edit on an IP by IP basis. It's really down to which way you like to work. I wanted to show you a couple of different ways to do the same thing. All right. We've now got our two roads sorted out. Now we need to start talking and manipulating the parking bays because if I'm looking here, you can see in the red contours here from my design model, there's quite a distinct kink going on in here. And if I look at the vertical design of that parking bay, which is the road to left for this one, you can see in here, let's see if I can rearrange the drawing a little bit. Um, the software is actually linked at the very beginning here, where it matches into the road, and it's linked at the very end. And it's done that using a couple of auto profiles. And you can certainly change these, but it tells you about that in that PDF. But the rest, it's basically done as a straight line. It's left up to you to design. So our job is to try and start making some level choices through here. So clearly this bit at the start would have to dive. Then this bit here would probably have to run generally in the same sort of direction as the road. And then this last section here would probably need to run back up towards the road or down, depending on whether I want this thing to park away or towards. So I'm going to use what we call a surface extension model. Now, if any of you came to our webcast last week, which Jonathan hosted a fantastic session on nonlinear strings, he used the surface extension in there, and I'm going to use it quite a bit here today. And I guess the reality is they are a very, very flexible and fast, easy way for linking models together on projected grades. So yes, it's a bit of a same function, but that's how functional and useful they are. Can't stress that enough. So the way it works, let me put in a few bits in the drawing. So this was the bit where I was talking about I was going to throw in a couple of labels just to show you the current grades. And then when I make some changes, you'll see the adjusted grades. So if I come in here and I say I want to do surface to slope and I want to do it against my model, add some labels and I'm going to pick on, turn my snaps off. I'm going to pick on this part of the world. So I'm going to go right from the road. And let's see if I can get straight. Oh, look, there you go. Close to straight. And then out to here. All right. So, oh, oops. Got to close this first. Then I can close this. All right. So currently the road crossfall here is 3% down and the crossfall across the car park here, which is this part of the world, is grading up at 5%, which is pretty obvious because this thing's sitting here well above the surface. So, as I said, this is where I use my extension model. So I come in here and I say, first model I want to make is related to road number 2. So I'm going to call this road 2 on the left. Give them unique names because when you go to pick them, you can only pick it by name. The string that I'm going to get calculations from is road 2. Change range. So I don't need to do the full length. I only need to do this one between 16 and 48. I am going to do this on the left, so it disables the right. The code I'm calculating from is the left edge of bitumen, and I need to extend out probably about 10 meters. So I build that model, close out of that, and you'll see in your CSD surface list here, there is now a new model, this one here, and it's actually that contour there. If I turn on the triangles, it should show you what it's done. Essentially what it's done is pulled out the levels of the edge of bitumen along here and then shot out 10-meter string cross section out over this side and set the level of that thing to be the current grade of my left edge of bitumen, which is 3%. Now that's going to leave the drawing very, very messy. So I might turn a few things off, turn that off, and we'll hide the contours. Task is easy now. All I do is go and use this auto profile function. I say I want to essentially reference a surface. The surface I want to reference is my surface extension road 2 on the left. And then I calculate that and I close out of that. And then I look down here and I go, oh, the labels haven't changed. And then I just come up and I refresh my models and all my labels update. And you can see there I didn't draw that completely perpendicular, but that grade is now 3% running parallel to that. And you can tell by the contours. Yeah, that's a nice smooth contour shooting off the side. That's what surface extensions are all about. Helps you to change what happens with your main road to your link strings. Okay, so let's have a look at that again, but this time we're going to pick on the right side. And this one's a bit more funky because this thing's a bit of a weird sort of L-shaped. There's a region in here which probably need a bit of design work. So the approach we might want to take for this one might be a little different. So let's get the surface extension built first. So we'll come down and run that. So we'll go surface extension. So I'm going to do this one a little quicker. I'm not going to really talk in great detail what I'm doing this time. We'll make the right-hand one. This one is row 2. The range for this one's a bit different. We want to go 27 to 60. Do it on the right. And the right code this time. That one, go a bit further. We need to go at least 12 meters. This is the crossfall method I was talking about. And I will play with this on the one on road 1. But you can actually use a code, which is the current slope of the code that you picked. You can use a value, so you type in a value, or you can actually use the code plus a value to do some sort of hinge. But I'll leave it on that, make that one. So then there's the other model sitting in there. And same deal. I'll close that off from display. Turn those off. Okay. Now, it'd be nice if you're in the vertical grading of this. Again, I'm running out of space here on the screen. Be nice to actually see where that surface actually is. That's where design constraints come in. So design constraint is a projection into the vertical grading window from something. Now, I want to project from a surface based off an alignment, which is the one I would like to use to be able to see that extension surface in this window. Actually, a few ways you could achieve this, but that's the one I'm going to pick on for this. So I'm going to say I want to add a new one. I'm going to call this thing something like surface extension. I'm then going to set up the values. So changes there, that's cool. The calculations are going to occur on Parking Bay Road 1. That's the alignment. So that's this one. And the model I want to pull against is, did I not build the model? I did build the model. Okay. Let's just get back in here and
I think the VG was possibly open at
thank you, Jonathan. Trap for the uninitiated. Yes, if the VGE is open and you build the model, the VGE has no knowledge of the new models. So yeah, got to kick open the VGE again, go back in, and we'll try that again. So we'll go from the surface. We'll call this the surface extension. It's parking bay on the right. Look, there it is. And we only want to see one of these things. So let's pick on, I don't know, let's go purple. So let's disable the lower crossfall adjustment. I don't want anything. Apply that. And why am I not getting it? Oh. Right. So now I'll actually bring up the right VGE. Okay. So we'll fix that. We'll disable the upper. Hey, there we go. So you can put these design constraints. Let's say that was intended. You can put these things on anything. So you can reference from one thing to another as many times as you want on any VGE. And I actually inadvertently did that onto the road too, which is probably completely and utterly not accurate for what I want to do. But what I actually want to see is that pink line. That pink line represents that 3% crossfall. And you can see some funky work going on here, and that's where the triangles are starting to get a bit weird as it goes around corners. That's fine. I don't want to design that bit. And then up here, it's going a bit, and I probably don't want to match in this time to the full extent. I want to match for potentially part of my model. So when I go and use that auto profile, when you do the reference surface, you don't have to use the whole length. You pick your range. So this one here, the first bit, I want to match from 0 to 6. And then I want to do it again, but this time I want to start at probably near the end, somewhere around 33. I think it's 33 I want. Yep. Um, Match to the other end. Click OK. And you can see it's linked in this bit here, which makes sense because it's kind of linking where it runs parallel to here. It's linking here where it's running perpendicular. But in this region in here, it's done nothing. It's up for me to design. Snapping reference. So most people probably still work on the concept that that only works on the surveyed surface or the natural, but it's not. It's any design constraint you make becomes a snapping reference. And I know Jonathan made this comment last week, and I'm going to make it again. So you can add design references in, sorry, design constraints in, and then snap to them, which is exactly what I want to do for this exercise. So if I then pick my design constraint as my reference and I start clicking on some points in the drawing, it's going to snap to the pink line. So I might want to snap somewhere around, I don't know, maybe here, and then perhaps sort of here, and then maybe here to begin to grade this. And then I could start to get in a bit funky and come into here and go, well, that actually needs a bit of a vertical curve. Maybe I need to put a 5 meter on that one, or maybe that's a bit big. So maybe I'll go, I don't know, 2 meters, smooth it out a little bit. I want to fit a vertical curve in here. So instead of me trying to bisect the angle, work out where I need to put it in, I can actually just use this tool here, which is to fit a vertical curve between two IPs. So I click on this, click on here, throws in the IP, projects the two grades together, and then fits in a vertical curve. And then I could come to the vertical curve and make whatever changes I want. And I'm just going to max it out. So I'm just going to say I want a massive vertical curve length. And it pretty much stretches it out until it hits one or the other IPs between. So I've used a combination of things there. I've used the surface extension to set some levels for the sort of the match in and then an extrusion. And then I've done some manual design in between. All right, let's go and have a look and see what that actually has done to my model. So if I bring up my model viewer view of the model, I can come in here and I can see that that's now sloping that way. And maybe I need to exaggerate a little bit. So let's go 2 times. So you can see there it's now sloping down. So it's running parallel. This side's actually running up. So you can see there, well, maybe you can't see, but the crossfall there is pretty consistent. Now I need to start working on this car park because this is way too low. So move that out of the way. Process to do this one is not dissimilar. So first thing we need to start with is, oops, not a point group, is a surface extension model. We'll add a new one in for this. We'll call road 1 left. And the string for that is road 1. The range for that would be a little shorter. So you can use these pickers. So I can come in here and pick a point in the drawing. So you go, oh yeah, there. Must be neat. I like round numbers. I'm an OCD engineer. We'll go to 38. This one's only on the left. I then want to pick from the LEB, and this time I only want to go, say, 5 meters, and we build the model. So you can see the contour that appears in the drawing. So we'll close out of this. That one there. There's the extension. So I'm going to disable its display because it's going to make this cluttered. I'm going to come back to the vertical grading of this one, and I'm just going to throw in that connection. So it is road 1 left. I didn't put the 1 in, but anyway. Bang, on the surface. Now if I go back to my model viewer, so let's just refresh a few things. And so now my model viewer, you can see there, levels are starting to get back to somewhere reasonable, but not quite. Wouldn't it be nice when I'm in this vertical grading or this parking bay to see this parking bay. Well, guess what? Design constraints is your friend in this case. This is where you can go and show another string. So I'll come in here and we'll call this the other one. And then I tell it the string I want to see is my road to parking bay right, that one. And let's make it say orange. And we'll reduce the search distance so it doesn't find it so many times. And we apply that. So what it's doing now is it's projecting me the vertical design from the other one in here as I am looking in parking bay number one or parking bay off road number one. So this is where I can start to make some design decisions. And this is kind of trying to, in VGE wise, it's showing me essentially this point relative to this point. This is where you can come back to your surface extension model. So if I come back over here and I go to my model and I start playing with the codes. So here I'm going to say, I actually want to do a code and value, and I want to add 2%, makes it essentially 1% crossfall. Build the model, close out of that. I refresh the vertical design in here, and you can see that it jumps up because the surface model changes, the vertical design redrapes. And then when I look at this in my model viewer, levels here are actually far more conducive to being coincident. And I could get in and start playing with this thing. I could potentially reduce the regions where I've got the auto drape, lots of options. But just wanted to show you that the dynamic nature of the surface extension model relative to the strings and also the ability to show one string inside another vertical grading.
Todd,
Yes,
just letting you know it's
I can see the
1:55.
clock.
It's all good. Fantastic. Thank you.
No worries. So as I kind of feared, I'm running probably short on time and high on content. So I guess in some ways this is potentially an inducement to get you all to come to next week's session where I may end up having to finish off some of the modeling that I wanted to show you in here. So let me see what I can get done in the next sort of 5 minutes, and then I will probably put a pin in it and then revisit the last couple of things next week. So the next thing I wanted to talk about was model builder and the surface modeling in terms of triangulation trimming. So let me set up to see if I can get that done. And then that's probably where I'm going to end it for this session. And then making the subgrade model I might do as the start of the next session. So it's kind of sits in two worlds anyway, because the subgrade model is a model, but it's mostly about output anyway. So it kind of fits into next week's session. So first things first, oops, that's not what I want. I want toggle display. Turn off a few things. So let's turn off model. Let's turn off these models. And let's just pull apart what the software did from a modeling perspective when it created the model builder version of this project. So if I actually look at what's happened, it actually uses the total model that it's built, which is just the roads in the network strings. So that's road one, road two, start left, start right, curb returns. But then it also throws in the parking bays. It then goes in and actually makes some edits on things like road one and road two to slice out the bits relevant to the parking bay connections. So the TM is all the stuff that the total model's done, which is just the chop off in regards to the intersection creation in here. And then the PA is the project assist or the project so AI, I think they call it. There's multiple names for it. Are the ones that the process did for me to join the strings together. Now, there's nothing stopping me making further edits to this. So what I thought would be apt in this exercise would be to actually talk about how I would modify my model, because I really don't want this thing to be battering down like this. I actually want this to be potentially a some sort of garden bed. So I just want it to fill across. So I can actually use my model builder tools in here to start making changes to my models. I'm going to pick on a string here. So I'm going to pick on curb return first. So we'll go to the curb return. I'm basically going to just go in and say I want to exclude batter. Just want to take it out for the whole length. And then the batter suddenly disappears for that string. Then I would do the same thing for row 2. I would slice out the right batter this time. So it's right batter because it's on the right-hand side. But I don't want to do it for the entire length. So I can use the pickers here to pick my regions. Um, Now, little side note. Um, it's been in the software for a little bit, but it's something that's probably not overly exposed. If I needed to add in a sample point I wanted to use for my model that didn't exist in my sampling regime, which is the stuff sitting here, you can actually use these add regions buttons. So add region allows me to add a start and an end. This one allows me to add just a start. This one allows me to add an end. So it basically opens up the insert sections command and allows me to add in my own values at the time of doing the edits. So if you haven't played with those things when you're in this part of the software, have a go at it. It's actually really cool. RBAT, I want to kill that off. So that slices it out there. I then need to do this for row 1. Need to get rid of the left batter, but I want to finish this after the parking bay. So say there. I then need to do it for this parking bay because I don't want batter in this part of the world. So this one is LBAT. Kill that again. I want to finish this probably about there. That looks good. And the last one, be this one, where I want to kill the right batter this time. Whoops, that's not what I want. I think. Oh no, it is on the right one. I did pick the right one. Brain's not working. Right bat, kill that. But I want to finish that sort of about there. Click OK, save, build, jump out. I'm going to turn the mesh on and the contours again so you can see it. So you can see here now that it's just removed the batter and it just triangulates across. If I look in my model builder, in my 3D world in the model viewer, sorry, the model builder model in the model viewer, you can see here now it's triangulated across. Okay, so that's essentially how you can actually just hack things out without actually modifying the cross section. I haven't changed the cross section for the those models, but I have modified it. Now you can probably also see here on the side there's a bit of excess triangles. So this is the last thing I'm going to have a look at, and then I'm going to throw open to questions. And I appreciate everyone persevering. But what I was going to talk about here is on the model builder surface, under the boundaries, there's been some new functionality added to the software that allows you to do retraction on the boundary based off a maximum triangle length, which could be quite useful depending on your the data and the complexity. But it also has the ability to trim by triangles, and it's already done some substantial trimming based off the batter codes, but it hasn't found everything. So if I turn that off and rebuild the surface, you can see all of these excess triangles come back. If I turn it back on, there's a couple of extra ones here that I haven't caught in my default values, which is these ones. You can actually use this tool here. You go pick triangle and you pick the triangle and it finds it, RBAT, R boundary, build it, slices it away. So if you need to do boundary trimming, if you've got a consistent code on the outside, then the filter by triangles might be a more conducive way to actually slice out your surface as opposed to the more traditional method, which would be to add a boundary, which is perfectly valid. I'm not saying don't do that. I'm just giving you other options in the box. All right. I have hit the end, Jonathan. I think I will park the discussion of subgrade model as a start of next session, which kind of lines up nicely with the process of next week.
I'd say that's a perfect bookend. Yes.
So, are there any questions?
Well, we had a few.
Yep.
I'll pick out some that I think would be relevant to what we're discussing.
Hmm.
Just someone was talking about, I'm probably not going to jump into it probably in here, but there was discussion around where the files for the AI. And if you guys have a look in the Q&A panel, you'll see that I've put in there as an answer to that question as to where they're stored, something that we don't probably need to be jumping right into now, particularly if not everyone wants to pick it up just yet. One of the questions that I thought was interesting was regarding, my webinar last year last week even. I did something similar to you, Todd, where I used quite a bit of auto profile to
Yep.
reference a surface or even a constraint for that matter. And the question has come in about excessive IPs and weeding them in in the vertical design. And I think it relates to the auto profile entries. And my response has been about using fitting or fit parameters as an entry in auto profile to weed there. So there we go.
The
Um, yeah, go on.
some of them have it built in, some of them don't. So if I look at reference surface here, it actually has the fitting built into that particular function. So you could just turn that on and then play with the fitting values, and then it would smooth it out afterwards. If you were using perhaps just referencing a constraint, there's no fitting option related to that one. But the fit parameters down the bottom here is you allowing you to add it to the sequence of the auto profile based on whatever it is you've done before. So basically, you specify your range here. So you can apply it in a multitude of ways.
Yeah, normally in my experience, you sort of put that as the last entry because the auto profile is it works from the top to the bottom. If the
100%.
last thing it does, it just goes through and smooths that particular section out.
Yeah.
Um,
Thank you. That's exactly what I was about to say, that the sequence of entries here is important.
uh, no, so that was a good question. Just in regards to the threads that Project Assist is creating, it might just be
Yep,
worth just reviewing exactly what Project Assist is doing. And I guess just to clarify,
there it
what
is.
it's doing is it's creating a series of actions. It is not going in and doing any modeling processes or using chainages to work with Model Builder. It is linking your strings together in a way where it will go and update any, for example, the auto profile. Sorry, Todd, I'm talking to this. I apologize.
No, 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 no.
Um,
You're on a roll. I've
I
got it
am
up
on a
on the
roll,
screen
aren't
for you. So
I? The auto profile entry that Todd just looked at, for example, is referencing a surface. And the way that a thread works, it essentially saves you the sort of the requirement to have to go back into auto profile and refresh it every time. So if you go and make a change to road one, obviously the surface extend changes, and then after you've changed the surface extend or after that model is updated, this vertical design that you're referencing also needs to be updated. And a thread is basically taking those actions and replacing them in a little sequence in a way where it will go and do it on your behalf. And I think the one that's most commonly used throughout the throughout this particular thread is the compute vertical geometry, which is basically go and rerun my auto profile, go and update my design data, and then go and do the next one, the next one, the next one, the next one, go and update my model. And that's
yep,
how it's built the thread. But you can go and build those yourself. I think we sort of very briefly touched on them last week. But there's an example of another one Todd's throwing up there, which is the
rebuild
rebuild
all
all.
is a really useful one. Now, here's something that most people probably don't even know about, and I want to jump in here, please, Jonathan.
Go for it.
You can actually you get one free thread to attach to this refresh button. So this refresh button is like the universal rebuild button in the civil site design tool space. But you can actually, under the tool space settings here, anchor a thread against it. So I can say that run this thread on the refresh. And if you want to recompute all of your vertical strings, every time you hit that refresh button, you could run something like the rebuild all, or you could make a specific thread for it and attach it to that refresh button. And then what happens is when you run that, yes, it's going to take a little bit longer, but it's going to do all those things that you want from that thread. So if you're finding that you're constantly having to run a thread and then run refresh, tie the two together using the tool space settings. Thank you, Jonathan.
Thank you. There's one more question that's just come in, which I
Yep.
think is quite nice to hopefully finish off. We are looking to kind of end the webinar, folks. So if you do have a question, please drop it in now. Just in Model Viewer, just being able to see the model line work. I've adapted the question, but the
Oh,
model line
whoops.
work and
Model viewer, not model. Model viewer or model
model, definitely
model.
Model Viewer. I don't worry, I have the same problem.
Oh, there's too many model things. I
Model
get
Viewer
get.
showing the line work and contours. So the question is about
Oh, okay.
contours, but line work for me is a good one as well. So
So
contours first of all.
so if you go to toggle display, you can configure more than just what objects are shown in here, and it's actually over here under contours. You can say, I want to see the contours, say, from my BM model, which is the one I'm currently looking at. Click OK, and then they will suddenly be in here. So it'll pull this way it's set up in the Surface Manager and throw it up in here. What was the other thing they wanted to show?
Just the object. Well, I wanted to show object
Oh,
display
object
tab.
lines. So it's this. couple of tabs on in the toggle display. In here, you can show the model strings, and I can pull up the model strings of my model I'm interested in. And so there you can see then I've got my crowns, edges, lips, backs, whatever it is I've got in here. So that's how you would turn that sort of stuff on and off in your model viewer.
Okie doke. Well, thanks, Todd. That was very, very detailed, comprehensive, starting from scratch and going to a lot of detail, and just some of the things that you may not have known about, like the just that fitted curbs button that sits in the VGE. Such a nice little button to have.
That's actually
Which
how the curb returns are done.
There you
The
go.
software is
Yeah.
running that stuff in the background.
So if you delete your curb return
That's
vertical
a
design, click that button
it's a really nice tool to
to bring
just
it back
project
in.
two IPs.
Which is great. And we'll get to see the result of those zero depth subgrades as well, because you put a lot of effort into putting zero depth subgrade on those
I did.
sections.
I was
We'll
setting
get to see
myself
those
up.
next week, which would be
Remember
good.
my statement at the beginning? Sometimes it's the Spider-Man point.
Yeah,
Great pain, or great responsive. Like, what is it? What's the bloody
that's right.
statement?
It's yes, exactly that. With
Yeah,
great
yeah.
power comes great
That's
responsibility.
it.
Before someone just jumps into the chat.
Yep.
Um, but yes,
Yeah.
look, that and actually some of the things you did with Civil 3D, there were things in there I was like, oh, I didn't know you could do that. So there was just some nice touches with the Civil 3D alignments, particularly that you threw in. So I'm going to be going back into this recording. It will be on the YouTube channel in the next 24 to 48 hours for you guys to have a look. So have a look at the feedback regarding this webinar. There will be a survey that pops up as soon as we kill this webinar, and you'll be able to tell us what you think. Please give us some feedback, even if it's just a thank you, whatever it is, or even if there's a webinar you'd like to see in the future, please drop that in there. And then Todd will continue with
Yes.
hopefully all of you next week, same time, the
Yeah.
design.
So yes, look forward to seeing you all. Well, not seeing, but look forward to getting you all next week. Stay tuned.
Fantastic. Thank you so much, Todd, again, and thank you all for your attendance.